Welcome back. I hope all of you have had a productive networking session and you had a chance to visit booth as well. We will now move on to another session, and this session is on hydrogen production technologies make in India. Now, between 2014 and 2018, India has invested a lot of money in the renewable sector. Now, thanks to this deployment at scale, the cost of solar, PV, wind, both onshore and offshore, and lithium ion batteries has come down quite significantly. Not just India, world over, we've seen large deployment of renewables in China and the US. And because of the scale, we saw the cost coming down. India has largely lost out on the benefits of manufacturing these technologies, which include high value added employment, increased tax returns, and the ability to innovate on existing manufacturing processes to develop the next generation of renewable technologies. Now, hydrogen technologies are not fully matured at scale as of now. India needs to be proactive in creating a productive innovation system for the development and deployment of hydrogen related technologies. Now, we've already heard of some developments happening in this regard, and there are some Indian startups who are already working on hydrogen fuel cells. Reliance Industries has also partnered with a Danish company, Stesel, to develop and manufacture hydrogen electrolyzers. So, are indigenous technologies being developed for hydrogen? What are the how far have they reached? Are these going to be cost effective? Can they be deployed at scale? To discuss this, I would like to welcome our speakers. We have Mr. P. Rahul, Senior Manager, Hydrogen at NTPC. He's spearheading the hydrogen engineering domain at NTPC. He's a mechanical engineer with an MBA from NSB IIM in Ahmedabad. We were due to be joined by Mr. Pradyut Maji, Head of Technology and Project Adani Group, but Mr. Maji could not attend because of a last-minute urgent meeting at the Niti Aayog. So I'm going to hand it over to Mr. P. Rahul for his presentation with the question that, we have the capability. We know of a number of PV makers in India, but largely if you see the projects in India, most of them see imports from China. So when it comes to hydrogen technology, world over it's quite nascent. What work is being done in India? What is NTPC doing? And what do you see the future like? What's your forecast like?
Okay, thank you. Thank you, Anisha ma'am, for a good introduction. And I thank the Gasification India 2021 team for giving me the opportunity to be present in this conference and put up my views on behalf of the whole organization of NTPC. I'll be just sharing few slides and then we'll be happy to answer to all your questions, whatever.
Yes, and this is a reminder to all those who are watching. Do send your questions, raise your hands. NTPC is a pioneer in many technologies in our country, running the biggest power plants in our country with a large capacity under their belt. Any questions, any clarification, Mr. Rahul is here to help answer them. So use this opportunity, type in your questions or raise your hands. Over to you, Rahul.
Yes, ma'am. Ma'am, is my presentation
we can see your
all?
screen. Yes, we can see your screen. We can start.
Okay. So, good evening to all the delegates present in the meeting. Myself, P. Rahul, I'm Senior Manager NTPC, and I'm part of this newly formed group. And I work under Mr. DMR Panda. He was supposed to join the meeting, but due to some urgency, he is not able to attend the meeting, and I shall be delegating on his behalf. So I don't know how this session has been, but I'll just briefly tell you about the green hydrogen, what green hydrogen is, what the green hydrogen economy is, and where India is actually standing at the moment. What are the opportunities, challenges, what are the unique economies, what NTPC is doing. So green hydrogen is something where you produce the hydrogen through water electrolysis, where the input power is green power, and then you generate hydrogen, store it or dispense it, and you three primary types of electrolyzers or broad types of electrolyzers. One is the alkaline electrolyzer, the second is the proton exchange membrane type of electrolyzer, and third is a solid oxide electrolyzer. It is said that the PEM electrolyzer is more RE following type and it has a good ramped up and ramped down facilities, whereas alkaline has been in this space for the past, say, 4 to 5 decades. though there was a different unipolar technology that used to be there for alkaline and still there. Now we have a bipolar one, which is more compact. And the SOEC, or the solid oxide electrolyzer, is the most recent one, which has the most highest efficiency, whereas the alkaline and in alkaline and PEM, alkaline has the highest efficiency. But as per NTPC's experience, what we find after interacting with so many of the vendors around the world is all three electrolyzers, in a way, with different configurations, can help or can get integrated with a green power solution, any green power, intermittent power. This is what we have experienced. So primarily NTPC has been technologically agnostic. In any of the pilot projects that NTPC is doing, we are not specifying any specific technology of electrolyzer, except in one of the projects where we have specifically mentioned that it should be PEM. Or otherwise, all the projects are technologically agnostic as far as the hydrogen production is concerned. So there are many colors of hydrogen, of this colorless gas, but broadly there are four categories. One is brown, the other is gray, blue, and green. Now in the brown hydrogen, which is made from coal or the thermal sources, these colors are not standardized at all. So you can assume that around 48 to 50 kgs of CO2 will be emitted from the production of 1 kg of hydrogen uh, through the carbonaceous sources like coal and oil. Whereas gray hydrogen, which is produced using natural gas, it is the cleanest form of the dirty hydrogen possible, and it emits only 8 kgs of CO2 through the steam methane reforming process. And the blue hydrogen, which is also very new, like the green hydrogen, in the blue hydrogen, we actually produce 1 or less than 1 kg of CO2 for every kg. And in green, it is almost nil CO2, only the hydrogen, only the carbon that is emitted in the manufacturing and production of the equipments involved in the process. For NTPC, green hydrogen is the cornerstone of our decarbonization ambition. Why this has gained so much of prominence in India, has been so much of euphoria all around, is for the reason that it touches almost all the energy intensive sectors, from green chemicals to steel to fertilizer to electrification to re-electrification. As an energy carrier, it touches almost all the sectors, and it has the ability to decarbonize even the very hard to abate sectors. So from here you can see green hydrogen can act as a very hub in the center, and this can touch all the sectors like mobility, petrochem, agriculture, fertilizers, chemical feedstock, heat, everything. And at NTPC, we want to be in every sector wherever green hydrogen is possible, practically possible. Here, I just wanted to show that how green hydrogen can impact every sector, and what is the quantum of CO2 that is being emitted by these carbon intensive sectors. Like, to produce 1 ton of cement, you require actually zero point 0.9 tons of CO2. And then at the extreme fag end, to produce 1 ton of ammonia, you actually require 2.82, you actually produce 2.85 tons of CO2. In steel, you produce 1.85 tons of CO2. So this green hydrogen has the potential to of energy intensive sectors. Now, where India stands. In this figure would elucidate that all the green marked regions around the world, they have already declared their hydrogen strategies, whereas the orange marked places, they are yet to finalize their strategies, but are in the process of making of these strategies. Now you can see India is also one of the countries where, though it is launched by the Prime Minister, but still we are in the process of finalizing and bringing the final draft, which is expected to be coming in next few weeks, I would say. And for this NTPC and many organizations have given their inputs and have worked closely for the development of the National Hydrogen Mission. So the National Hydrogen Mission has two phases to work with. In the first phase, 21 to 24, it actually has these areas where it wants to focus itself, like market push sort of thing, niche market application pilot projects just to introduce the technology, few infrastructure development projects, hydrogen hubs, and R&D and public awareness campaigns. Whereas in the second phase, it is assumed that it is a medium-term phase to long-term phase where the hydrogen market development would actually start and then end. And here, and by 2030, we can assume that the market would mature for the hydrogen technologies. So, just to quantify what can be the potential of this green hydrogen, we have taken a very conservative approach based on the draft. Is if you give a 0.15% mandate for the green hydrogen consumption obligation only for the ammonia and petrochem sector, so you would be needing around 30 megawatt of electrolyzer, and you would be abating around 0.11 million tons of CO2 annually. And if this mandate is increased in a trajectory mode to say 10% by 2030, you would be abating around 10 million tons of CO2, and 2.7 gigawatt of electrolyzer would be required only for these targets. But if government comes up with more aggressive targets, it will create more demand, and supply side also will gain significant support. Now, what NTPC thinks as a standalone basis is what can be the future for these green hydrogen technologies by 2030. We anticipate that around 2,500 fuel cell buses can easily fly, and we can have, say, around 100 hydrogen refueling station with a vehicle to refueling station ratio of around 25. That would only require a gigawatt of electrolyzer capacity. In the fertilizer sector, we assume that 20 gigawatt of electrolyzer capacity would be required to produce green ammonia only. Then in the microgrids in the far off regions of Ladakh or Andaman, we have a potential of around 650 megawatt of electrolyzer. And if even if 10% of the city gas distribution is blended with green hydrogen, we will be requiring around 2.5 gigawatt of electrolyzer. Overall, around 30 gigawatt of electrolyzer would be required for domestic use. In the petrochemical sector, we alone would be requiring 5 gigawatt of electrolyzers and around 4 lakh tons of green hydrogen a year if we just replace 10% of the natural gas with green hydrogen. And how India is uniquely positioned on what are the opportunities and definitely the challenges are abound. The opportunities in India are, I mean, there are many opportunities. One is the lowest tariff possible, this everybody has been talking about, and coupled with the ambitious target of the government to have 500 gigawatt of non-fuel fossil capacity addition by 2030. And one figure that touches me a lot is because there are at least 30 million cars flying on Indian roads, only cars. And if you take an average of 50 kilowatt engine per car, you have a potential to decarbonize around 4,500 gigawatt of engine power in the automobile sector. So it only presents a lot of potential for the green hydrogen to gain substantial ground on this. Then we have very high oil demand in India. We are already handling 6 million tons of hydrogen. We import 85% of the oil, whereas the 53% of the natural gas is being imported by India. So we have a very strong domestic demand. These are the opportunities for flourishing the green hydrogen. Now, what are the challenges? Challenges are abound. I'll talk about the challenges later. A very recent study by the NITI Aayog has indicated that by 2030 we can have around 5 million tons of green hydrogen requirement, which would catapult to around 25 to 30 billion tons of green hydrogen. And a very conservative, also to say ambitious target is to have 60 gigawatt of electrolyzer by 2030 for domestic purpose alone, whereas 100 gigawatt of electrolyzer capacity for export of green ammonia or green hydrogen. Challenges are we don't have manufacturers for the supply of electrolyzer modules. but for electrolyzer modules and for the compressors, we don't have any manufacturer as such. Few manufacturers are coming up and have good potential. For that, government is coming up with the PLI scheme where domestic manufacturing of electrolyzer, it's a very good step. It will be encouraged through the PLI scheme. Then there are no codes and standards for the new use cases of mobility, or say domestic cooking and or heating, domestic heating, or any of the recent use cases of the hydrogen. So we need to either, we have also given our inputs to the CEA. So these standards need to be adopted as quickly as possible, whereas all approvals for the new hydrogen refueling stations are being accorded on case-to-case basis, whereas we need to have good standards and a good standards framework for the hydrogen as soon as possible. This is also part of the National Hydrogen Mission. Now, coming to the most important thing, we have green hydrogen in India. It is very much possible. We had a large amount of green hydrogen facility at the Bhakrarangal Dam, which was in a way a very green hydrogen source to produce ammonia. But the cost of green hydrogen is 3 to 4 times of that of the gray hydrogen. So we need fiscal support incentives and other viability gap funding. I'll just touch upon the unit economics of what green hydrogen is. As of now, a very best case in India would require a $3 to $4 a kg to purchase 1 kg of green hydrogen. Whereas by 2030, it is very well possible to have it around 1.5 to $2 a kg, and 250 by 2050 it will be a sub-dollar kind of thing. Now, if you take green ammonia, we find that green ammonia has the potential or the for early adopter, as an early adopter use case, we can find green ammonia to be fitting well. You can see India, or NTPC for that matter, has quoted the lowest tariff of say 1.99 or 2 rupees per kilowatt hour. That amounts to around $26 a megawatt hour. So if you see, with $26 a megawatt hour, even 580 to $600 per ton of ammonia is possible, which is actually the import rate of ammonia as of now because of the rising natural gas prices. So this is very much possible, and in times to come, say around 3 to 4 years down the line, we can have a very good market for green ammonia, and India should seize the market. For that, government is bringing in green hydrogen consumption obligation. That was also one of the factors or one of the ideas proposed by NTPC to the government and by many other organizations probably. But that has been taken care well, and government is bringing good demand for the green hydrogen through these obligations. In mobility, if you see the total cost of ownership or the amount of money required to run 1 kilometer of fuel cell heavy duty vehicle is around 1.5 to $2 a kilometer. Diesel, here it's shown $1 a kilometer, but it is sub dollar a kilometer, say around 50 to 55 rupees. So now it becomes 3 times the cost. Whereas by 2030, we can see that FCEVs, or large scale fueling station with large scale deployment of buses, would reduce the cost to say around $1 per kilometer, or equivalent to what the diesel run buses today are. It is very much possible. It is also a very early adopter case. So my idea of showing those early adopter cases is because NTPC has done heavy analysis on these, and NTPC is putting its own money, or say putting its risk capital to have these pilot projects just to gain learning and to enter the market very early and be a front runner in the race for green hydrogen. So what NTPC is doing, and what is NTPC's vision? NTPC wants to supply reliable and cost-effective green hydrogen, and it wants to touch every value chain across transport, industry, and the power sector. We are having 2 pilot projects. At Leh, we would be flying 5 hydrogen fuel cell buses in and around Leh, say covering around 150 to 170 kilometers a day. We are building a solar plant there of around 1.7 megawatt, and then a hydrogen refueling station, which would be producing hydrogen in situ during the daytime from the solar plant only, and then storing it and dispensing it throughout the day. For this, we have got the land, we have started the geotechnical work. Geotechnical has been completed, and the award for the contract of solar in the early stages of this. If all the land and everything, all the approvals have been received, and possibly Prime Minister of India would be laying the foundation stone of this project very early. Now at Delhi, we want to set up a hydrogen fueling station at Badarpur, where it would be filling 5 fuel cell buses for the intra-city transport from Delhi to Agra and Delhi to Jaipur. 3 buses from Delhi to Agra and 2 buses from Delhi to Delhi to Jaipur would be deploying. One of the very good projects that we're doing, we are first in India and probably few in the world to have started this project. We want to generate hydrogen during daytime at one of our guest houses in one of our premises at Vishakhapatnam. We will be generating hydrogen during the daytime, storing it, uh, compressing it, storing it, and then generating power for the next 14 hours through the fuel cell system there. So it is a 50 kilowatt system, whereas the electrolyzer would be around 300 kilowatt module. This work has already been awarded to MS Bloom Energy, US, and its Indian subsidiary, and supplies would start soon and would be seeing this project uh, actually getting commissioned in 6 to 8 months. Then we have a backup power system replacement through hydrogen, the same technology, but the difference here is we'll be generating or trickle generating hydrogen throughout the day, a little bit of hydrogen throughout the day, and we'll be storing it. And then whenever there a power failure occurs, we would be using it as a DC generator. So here we have a very big fuel cell and small electrolyzer, whereas in Vishakhapatnam we have a large electrolyzer and a smaller fuel cell. So we are doing this to have it as a pilot and then quickly scale it, learn from it, quickly scale it up to off-grid regions as well as the urban regions where DG sets are being banned. This can be one very good option. Then at one of our townships, we are actually having a pilot project where we'd be blending, to start with, we would be blending green hydrogen up to 5% by volume to the PNG network there, and we would be sending the gas to 200 homes. We are planning to have it a very close watch case where safety aspects, material degradation, and continuous monitoring, everything would be done. This would be the first in India and one of the largest in the world to start with. If this succeed, we'll then try to propose and do advocacy to the government to have a mandate and have blending throughout India, and NTPC will be a stakeholder in this. Then on the green chemicals, which has a lot of potential, specifically green ammonia and green methanol. Green methanol we'll be producing at one of our plants where we'll be capturing around 14 tons per day of carbon from the stack of the thermal power plant, generating 2 tons per day of green hydrogen, then converting it to green methanol. And this green methanol is a one-to-one replacement of light diesel oil or petrol in the vehicle, where you can actually blend 15% of this green methanol with the existing petrol and very well use it. And we are also planning a fertilizer plant where we'll be generating green hydrogen and putting it in the existing stream of the fertilizer or urea producing cycle, and will be, or the green ammonia production cycle, and part of that will decarbonize the ammonia. I mean, on pro rata basis, if we put X percentage of hydrogen, we will be getting some partial green ammonia from the cycle. So to start with, we will be doing that. So this was all from NTPC side, and if you have questions, I'll be happy to share with you whatever I know of this sector. Thank you.
Thank you, Mr. Rahul, for your presentation. And for now, we are not seeing any questions coming in, but if anybody has a question to ask of Mr. Rahul, okay, Mr. Desai is asking a question, I'll just hand over the mic to him. Yes, please go ahead, Mr. Desai. You can go ahead and ask your question.
Hello. Very nice presentation, giving a beautiful landscape what NTPC is going to do it. But you are silent about your own thermal power plants.
Mhm.
So what are plans there?
We have around we are over 67 gigawatts of thermal capacity, I would say. These capacity would exist, and we have formed a subsidiary, wholly owned subsidiary, which is NTPC Renewable Energy Limited. I am also an employee of that company. This company has a target to be a 60 gigawatt renewable company by 2032. So whatever we have done in the past 40 years would be done by this company in a very short period of 10 years. And so in that case, if you see, we'll from say 98% or 95% thermal company would be transitioning to say 40 and 50% thermal company and 60% renewable company if you take it as a group.
And any plans for the new supercritical power plants that is beyond 1,000 megawatt capacities?
Sir,
Because there
actually,
I foresee a good possibility for supercritical plants, the new plants, the revamp or new, whatever it is.
as of now, as per our company's decision, there is no plan to bring in any thermal plant. But recently, there has been some support from the government to bring in some brownfield projects which are under discussion. But hitherto, we were not thinking of any thermal plant for the past say 2 years. We are only focused on RE and existing plants that are in under construction. Definitely, that will be coming up. So we had signed around 1 lakh megawatt or 100 gigawatt of PPA, but we would not be, though we can construct plants, but we would not be going and cashing those PPAs and bringing in more thermal plants, except if government says and if any base load requirement exists in future.
Right. We have a question from Mr. Vivek Kamal. Mr. Kamal, go ahead. Please start your mic
Yeah,
and your camera and go ahead and ask your question.
yeah. Yeah, good evening, sir. This is Vivek from L&T. I have one question regarding what is NTPC's pathway regarding use of the solid oxide electrolysis in terms of having you have already high temperature steam in your plants. Do you have any pathway, maybe not optimistic, but in by let's say by 2030? Can you throw some light on that?
Yes, the one that I talked about, this Visakhapatnam one, the 50 kilowatt microgrid that we are about to start construction. The electrolyzer there is SOEC type electrolyzer only, solid oxide electrolyzer, and the fuel cell also is solid oxide fuel cell for those projects. And you're very right that we are planning to have synergy between these thermal plants and the green or the electrolyzers, and use that thermal energy to, I mean, supply the thermal or heat to the SOEC electrolyzer, so that we save on the input electricity. Because once you supply a thermal part of the thermal energy, you reduce the requirement of input electricity.
Right. Mr. Dhamal, I hope your question is answered. Okay. We have Mr. T.S. Venkatramanan joining us. So please go ahead, ask your question.
Yeah, can you hear me now?
Yes, sir. Please go ahead, ask a question.
I missed part of this presentation because I lost internet here. I want to, Mr. Rahul, can you explain to me, if you are not done already, what are the steps you have taken to do gasification? Because this is a seminar on gasification, on coal gasification. What is NTPC's plans and roadmap? How do you want to do it? Do you want to go to IGCC or do you want to develop them to BHEL? What are your plans? How are you looking at it to address this coal gasification?
Sir, we actually we moved ahead and we were exploring a few of our areas where we can do coal gasification, but then it was kept at abeyance by NTPC because we don't want much to focus on these thermal technologies. So we were in talks with Ergo Exergy and all for the coal gasification at some of our mines that we have. but then company took a decision and said that no, we'll be going green. We won't be concentrating much on those. So
That's
as of
very,
now, everything is kept in abeyance.
that's very unfortunate because there is Atmanirbhar and PM announces 100 million tons of coal in the next 8 years. And we are all looking at small projects, as I was telling yesterday, like methanol and all those things, RDF gasification. All that is not going to make a big dent. And unless people like you, NTPC, moves into the act and do something about it, I know IGCC is not necessarily the answer, but you can do gasification to produce renewable diesel. So even from coal, we can do that. And that's a well-known technology. And people are there ready to offer. So it's a proven. So why, like China, why are not moving that direction? We can
Right.
start import.
Mr. Venkatraman, Mr. Rahul heads the hydroengineering business of NTPC, and some of the questions being raised by you perhaps would be better answered by the more senior management board members who then take a decision on which technology will be adopted in the end. He's spearheading the hydrogen engineering cell, and he's given us a presentation on that. Let's hope that NTPC will go ahead with plans for gasification, given that they are doing coal combustion for such a long time. But Mr. Rahul here is actually heading the hydrogen engineering cell in NTPC.
Okay, let me then change the question. Why not we looking at blue hydrogen from coal gasification? So I'm not going to let you go.
No, you are right, actually, but we haven't seen any good project in India as far as coal gasification is concerned. One of the projects, I think, in West Bengal, which was envisaged to come up, never came up for the coal gasification. But there, you're right. There exist opportunities where we can capture the carbon, and this can a blue hydrogen sort of thing can become a success. So that's what we are doing in green methanol. If you see, we would be, if this succeeds, we are making a very big investment in one of our plants where we'll be capturing from 14 to 20 TPDs of carbon dioxide from the chimney, and then we'll be generating green hydrogen from a 5.5 megawatt of electrolyzer, and then we will be reacting it and producing green methanol. So this, if you say, it is a source, sort of carbon capture and utilization, because we don't have a good reserve to carbon capture and store it underground.
Okay.
So if this succeeds, we'll definitely I mean it will be a so-called blue scenario, if you say, once you capture the flue gas.
Yeah, CCUS is coming, and we should think about it not only for blue hydrogen, also for green hydrogen from biomass. In fact, I have not
Yes.
talked about it yesterday. You get into gasification, let's do the entire rice straw into biomass to gasification, produce even blue hydrogen.
I think he got disconnected. Ma'am, you're not audible.
I'm sorry, Mr. Venkatraman. I don't know, for some reason you were off the stage. I would request you to please raise your hands if you wish to come back to the stage. Mr. Dalvi is on stage. Mr. Dalvi, do you want to go ahead and ask a question?
First of all, I'd like to thank Mr. P. Rahul for being here. And if Dr. T.S. Venkatraman is around, I'd like to really mention that Mr. P. Rahul has joined us at the last stage. He has been replaced by Shri DMR Panda, and they are from NTPC Renewable Energy Limited. The NTPC Limited, where we were interacting with the directors, Dr. Ujjwal Kanti Bhattacharya, and the others, Dr. Venkatraman, they are the ones who can answer more on coal gas. Am I correct, Mr. Rahul, in adding this to
No,
Mr.
sir.
Venkatraman? Now,
Yeah,
right. And Mr.
correct.
Venkatraman, now that you're around, we also have one of our sponsors, Navali Lignite Limited. Unfortunately, there are none of the questions come from there. NLCs, you're also an advisor, Shri Venkatraman, to Navali Lignite. So, would you like to throw some light on lignite gasification, which NLC has done in India? Maybe that would help the audience. Mr. Rahul, with your permission, I'd like to
Yes,
invite
yes.
Mr. Venkatraman on stage as
Yeah,
well. He's also
I'll
an
invite
advisor
him
to
on
NLC.
stage. Yes. Sorry, Mr. Venkatraman, you were cut midway.
Yeah,
And Mr. Dalvi also would request you to please throw some light on lignite, since you're
Yeah.
an advisor to Naval Lignite as well.
I heard that. It's good for Dalvi to interject me, no harm, because that is something I want NTPC also to concentrate, because when I'm close touch with the CMD of Neyveli for the last several years, and 4 CMDs have changed. So since I talked on this gasification from 2013, now this latest CMD, without any reflection on others, is very well tuned to make lignite gasification turning into methanol. So I proposed 1 million tons of methanol per year, which will have 4 million tons of lignite consumed per year. So this is a good project. Then they took it up. We could not do the feasibility study because we are a small consultancy organization. So they gave it to PDIL, which is also a government organization. And they have finished almost the PDIL went about a smaller scale, 1,200 tons per day of methanol, which they had to scale it up to 2 times, 3 times. So the point I'm making is methanol is not that attractive yet, because the international price of methanol has gone up now temporarily because the natural gas price has gone up, Rahul. So if the methanol is go back to 20 rupees a liter, then we can't make it from a lignite. The feedstock is very expensive. Even coal will be there. 5 projects on coal. Are you aware of that? 5 projects on coal and methanol. Talking about we are going to do 7 million tons.
Right.
Coal utilization.
Mr. Venkatraman, we have a few more questions. So with the permission, I will hand over the mic to another participant. We have Prakash Thanki, who I think wants to ask a question to Mr. Rahul. So I'm just taking him on stage. Yes. Yes, Prakash, please go ahead.
Hello.
Yes,
Hello.
please go ahead.
Yeah, Mr. Rahul, I just wanted to understand a little bit on energy balance of the hydrogen fuel cell. So how it would be, whatever the energy we are putting it into a consideration like hydrogen generation from onwards, or whatever the energy we are operating while the fuel cell, how it would be, like how we calculate the energy balance in this system.
Fuels. So see, there are two things. One thing is, if you take it to, if you consider this a system of having it as an energy storage system, if you consider it to be an equivalent of a energy storage system like a battery, where you put in electricity, you give input electricity, then you store it for some time and then use it. So in hydrogen also precisely we are doing the same thing. We are putting in, giving electricity, generating hydrogen, storing it, and then again converting it to electricity. Now, if you take this, the round trip efficiency, best round trip efficiency that you can get is 35%. It's very simple. Electrolyzer has an efficiency of 60 to 70%, whereas the fuel cell has an efficiency of 50%.
And its designing would be kind of battery system like depth of discharge, number of cycles.
See,
That is the thing, or how it would be.
see, it is. I mean, if you want me to give some analogy, I'll give. If you take the hydrogen system, and if you want to know how it relates to the energy storage capacity of battery, like say megawatt hour or kilowatt hour, here you correlate it with a kg of hydrogen that you store in a tank. So these two things are equivalent. And if you want to know the capacity or the peak output of the battery, say if the battery peak output is 10 kilowatt, and then in this case the fuel cell capacity would act as a peak output of the battery. So you need a 10 kilowatt fuel cell.
All right. I hope
Okay.
that answers your question.
Yes.
Thank you.
Thank you.
Right. So, Mr. Rao, thank you so much for your presentation. Now, for the last 2 days, we have had participants who have heard many senior leaders talk about the promise of gasification, the road ahead, and today we've spoken largely about hydrogen and how brown hydrogen perhaps could be the most cost-effective way forward. I know you are spearheading the green hydrogen part at NTPC. And there are some plans being made by other companies as well to bring in green hydrogen. But we've done a lot of discussions on hydrogen today. So I would like to request some of our participants here, if they can raise their hands, they can come on the stage and they can recount their experience on what it has been like, what they've learned through these 2 days, and what more would they like to hear about. And I request the participants to please raise their hands so I can bring you on stage. Raj, there's one more question that has come in. And I'll just show you the question. Okay, the question is from Mr. R.R. Desai. Yeah, I'm going to hand over the mic to him. Let him ask his question.
Hello.
Yes, Mr. Desai, go ahead.
This is we are very clear that clarification was good, that you are only from hydrogen and green hydrogen side. So asking about thermal power plant is not the right. Sorry for that.
No, sir. My 90% of my experience rests with thermal plants.
So,
Like
this is the midway question. This is the midway
Yeah.
question. What I put it.
Yeah.
Amisa, you can put it on the screen so everyone can read. It's a bit longer question.
I'm
If
trying,
we-
sir, but
anyway, I can say it. See now, flue gas desulfurization available at most of the thermal power plants. Your flue gas is more cleaner. So, do you feel that harnessing carbon dioxide is simpler and then converting into hydrogen, gray hydrogen, or methanol or whatever route? Whether FGD will make a difference, by which the ROI of FGD also. See, these all are interconnected. No energy is independent or in isolation. Your opinion, please.
Sir, if you see what FGD does, it removes the SOx emission. Now, if you see, while we talk about these colors of hydrogen, we only talk about the CO2. We don't talk about the SOx and NOx. Now, if you see, if you generate gray hydrogen, or for that matter brown hydrogen, if you're not able to capture the CO2, that doesn't add to anything.
Correct.
And in all COP and everything, we are only talking about CO2, though there are 6 gases that contribute to greenhouse effect. But we are only talking about CO2, and here also, in case of hydrogen, we are only concentrating on CO2, not the SOx
Absolutely.
and NOx.
But with FGD, the harnessing CO2 becomes simpler or not? I think it is. See, before 10 years, taking flue gas and harnessing CO was very, very difficult, according to me. Now with FGD, this is just an idea. We can brainstorm more, or there could be any forum where we can talk. That's the only point. No need of answer now. As
Right.
Anisa said, that express yourself. So
Right,
this is
right,
just an
right,
idea.
right. You might be right, sir.
right. And Desai, the question of SOx NOx is deliberated at length during our SOx NOx summit as well.
Yes.
And that is also a platform where we raise these questions. So once again, a request to the participants who have been patiently listening and who have attended some of the sessions over the last 2 days, please raise your hands and recount for us your experience over the last 2 days. If you raise your hand, I'll get you on stage, and we'll be able to talk about what have been your learnings, and what more would you like to hear of in the gasification summit, which of course will return in a year's time. So do please raise your hands, and
30 seconds on me, because as I'm already there,
please.
it was a fantastic experience. And juggling between 2 tracks was also very enriching. All the questions were good, and all the presentations were good. And panel discussion was fantastic. So instead of individual PowerPoint presentation, more panel discussion could be arranged. And one suggestion, the question answer, it means that as if one person is asking question, like we have TSR, such a learned person, if he monitors, or he controls the question to 3 learned speakers, such kind of session also can be conceived. Just an idea.
Right. Thank you for your suggestion. I would also request some of our sponsor participants to share their experiences, what kind of feedback have they received. So please raise your hands so that you can come on stage. Mr. Desai, anything else that you'd like to say to the audience?
Thank you. Thanks again.
All
2
right.
thanks for 2 tracks. Two thanks for
Alright.
2 tracks.
All right. Thank you. Thank you for joining us on stage. Right. Again, I would request some of the participants if they can raise their hands and come on stage and just recount their experience during the last 2 days where we have discussed gasification, and today we discussed hydrogen. So we got Vivek Thumal, who is now coming on stage.
Hi.
Yes, Vivek, can you put on your video
Yes,
as well?
yes.
Vivek,
Sorry,
yeah.
sorry for video. I can continue with
Okay,
audio.
please,
Some
please
issues.
continue.
Yeah.
Yes.
I want to congratulate Mission Energy for organizing this very nice conference. Basically, we learned a lot, and you have compiled very good topics like gasification with combination of green hydrogen. That is very something that we are very happy with that combination, because we are thinking some of the thoughts which we are using in gasification that lead us to the finding the solution with the help of green hydrogen, and that is the path forward. And through these lectures, specifically from the JSPL's experiencing in operation of this coal gasifiers in the steel plants, and how they are operating, and their experience is very very helpful to us in the upcoming days. So that's it. I wanted to say very thank you and congratulates once again to Mission Energy. Thanks.
Right. Thank you so much, Mr. Dumal, for recounting your experience. And it's true, actually, real life experience counts a lot, and you learn from what people are doing, the mistakes they've made, and you try to avoid them, and perhaps run a little faster with it. Thank you so much. Now I'm going to have Mr. Venkataraman come in, and I think he also wants to say a few words about the conference. Please go ahead, Mr. Venkataraman.
Yeah, I just want to not only just congratulate Mission Energy, with whom I've been there for the last 7 years, known Anisha also for a long time, but the most important thing is the concept in which they combined gasification-based energy. See, the idea is all the energy need not come from gasification. In fact, on waste energy, some of the platforms like fermentation to ethanol to sustainable aviation fuel is not from gasification. So secondly, even Lancetech, what they did is taking a syngas, from there they're trying to make ethanol and then aviation jet fuel. So some of these concepts, syngas, maybe they can take it from anybody, so there is no need for presentation. So they all come under waste energy. So this time I was happy to present on the real waste that is confronting the nation is MSW. So I must thank the organization again for giving me the opportunity to air that. I will take it up next level to Niti Aayog. Already sent my presentation to Niti Aayog, to Dr. Saraswat. So I want to discuss if I am in the committee of the gasification technical standing committee. So I will take it up there, and also definitely mention about Mission Energy's zeal in which they are proceeding every year. Thank you very much.
Right. Thank you, sir, for your words of appreciation. I would request Dalviji to please raise his hand. I would request him to come on stage and say his few words. Right, he's here. Over to you, Dalviji.
Thank you so much. Thank you, Anisha. Thank you, Rahul Saab, for being on stage. And I'd like to thank all the participants here. I am humbled sitting in front of all of you in the chamber, rather, or the studio of Sri Ashwin Kumar Khatri, our Director General. Now, Ashwin sir is also known as the gasification man of India since the last 13 years. I remember a parallel conference that we are doing simultaneously as I speak here on waste to energy. I remember Dr. APJ Abdul Kalam, the former president of India, had graced his presence when we had done this conference at the NDCC convention centers almost a decade back. And Dr. Kalam had his dream of India running on biofuels. So from then onwards, of course, the journey on coal gasification began. There were a lot of companies, ConocoPhillips, Phillips 66, Lumus Technologies, of course, they have done a lot of work with Reliance. Reliance Industries Limited, a personal note of thanks to Sapre Saab, to Executive Director Saab, in fact, Hitalbhai Miswani, and of course, the gasification god, Sri Thomas Matthew. And ladies and gentlemen, if you have noticed over the past 2 years, several years, and even yesterday, the zeal with which Sri Thomas Matthew comes, he was in his hospital bed. Still, he made it a point that he will address us for the benefit of the gasification fraternity. And Thomas Saab did speak to the audience. Of course, I'd also like to thank Sri Nitin Karvekar ji. And of course, today we had presentations from Sudhakar Davra and the entire team from Reliance. A special note of thanks also to VR Sharma Saab from Jindal Steel and Power Limited for his insightful presentation yesterday. Of course, this year we missed the presentation, or rather a keynote address from Sri Naveen Jindalji, the Chairman Managing Director, also was earlier Member of Parliament from JSPL, Sri Naveen Jindalji. And but of course, he is with the subject, and Naveenji's support is with us. Also, a special thanks to Neyveli Lignite and everyone. Yes, Ashwinji normally does this vote of thanks and gratis. We also have a lot of award ceremonies. However, this year, because of this medical exigency, Ashwinji could not be present, but he was making a point that even from his hospital bed, he stays connected with the audience. It is not just this conference. After this conference, we will summarize it, and we will also send a collective voice of the industry. And I think, this Ashwinji deserves an applause for this. A collective voice of the industry, which will be sent to Niti Aayog. Of course, we missed Dr. Saraswat Saab. There were a few others who were there. But we will see it to a point that I'll personally go and meet Sri Amitabh Khan Saab, Sri V.K. Saraswat Saab, present him as to what we have done. Of course, the Gasification Council of India as well, and various others. I remember me and Ashwinji, we had visited New Delhi, and we had met a couple of union ministers. Of course, we missed the presence of Sri Hardeep Singh Puri, Minister of MOPNG. But of course, I am really indebted and thankful to Sri Vartika Shukla, Madam of Engineers India Limited, who, in spite of her travel itinerary and busy schedule, could send us a recorded message of the theme and what is the dream and what could be achieved, and what is the projection of Engineers India Limited. Of course, note of thanks to various other sponsors as well. And with this, I'd like to also make an announcement that if all goes well, Anisha ji, and this is if all goes well, we don't have to be more on an interface doing programs online, but we will reassemble next year. I'm keeping my fingers crossed in a 5-star facility somewhere around New Delhi, preferably the Taj Vivanta or the Taj Palace, where we will meet and greet, share each other. Cocktails are not just for enjoyment, but they are powerful business tools, where we could also have our sponsors exhibit. We'll have footfalls, we'll have people meeting, and of course, having one-on-one interactions. That's a promise. So it all depends, God willingly, God forbid that the third wave doesn't come, and God willingly, everything one is sound, safe, and healthy. We'll definitely meet again every year for gasification initiatives. With this, on behalf of Ashwin Kumar Khatri, our Director General, I'd like to thank all participants. And if anyone still would like to, raise his hand and would like to share something with us, over to the Queen of the Castle, Miss Anisha Dhawan, who has so beautifully managed the conference over the past 2 days. So with that, I'd like to thank, and Anisha, madam, over to you. Thank you.
Thanks, Alviji. I'd again request participants here who have attended the 2 days of sessions to please raise their hands and recount your experience here, and also give us suggestions on what more you'd like to see. We've heard some suggestions coming in for more panel discussions, for curated question answer sessions. So if you have some suggestions, do raise your hands. We'd like to take you on stage so that you can give us your suggestions and recount your experiences. Okay. Yeah, the presentations are being shared on the WhatsApp group. And of course, you will have the YouTube links as well. So you can see the presentations there in case those presentations don't open or there are any issues there. You'll have YouTube links for each of these sessions where you can replay all the presentations that were played out by our presenters today. If any of you would like to raise your hands and come on the stage to recount your experience, so that would be great. If any of you would like to do that. Okay, so I think we'll wrap it up here. All in all, I would like to believe that the participants greatly benefited from the deliberations that went about during these 2 days. And we've had great speakers with amazing presentations and lots of information that has been given out. So we have Mr. Desai. So I'm going to give the mic to Mr. Desai. Yes, Mr. Desai, go ahead.
Actually, I did not want to come again to give chance to others, but as no one came, this is a very big comment from my end. That over the years, Mission Energy has become much more than a platform or an event. Now your role, what I look, this message can be sent to Mr. Khatri as well, that your role has catapulted to such a level that you need to act as a coordinator between all the three main pillars, the fabricators, the users, the processors, as well as various and at the ministry, without encroaching to various ministries, a coordination tool, a coordination platform, your organization can, your foundation can take care of. That is my suggestion.
All right. Thank you so much.
And what I said, the question answer, what I said, it could be interview level. What I suppose Mr. T.S. Venkatraman taking interview of 3 experts, that could be my dream. It is not question answer, taking interview. It means he can change the questions and will make very live. That is a suggestion. Thank you.
Thank you, Mr. Desai. We have Mr. Venkatramanan with us. Let's see if he'll take up your offer. Mr. Venkatramanan, did you catch what Mr. Desai suggested?
I'm trying to come on the video. So let me see. Yeah,
yes,
I want to thank Mr. Desai. That's a good suggestion. I would love to do that so that we can sit as a moderator and get everybody to speak very precisely and deliver strong messages. This is what I like to do. And then secondly, I want to see Mission Energy become like a status of CII. So CII has the ear of the government. So I want to have Mission Energy not just going inviting people to come and inaugurate and then do the keynote speak, etc. And I wanted to send the proper minutes of the meeting or say, or not even that, take a few takeaways. What's all these conferences done? What is I told you? What is the thrust you want to give to the government? Put it across. It could be even part of the budget. So I think this you should go beyond this. Your role is much bigger than this, as Mr. Desai said. You are just now organizers of this, which is Khatri has done it very well to initiate it. But with your team, Anisha, you and Dalvi, all of you can take it to the next level. And that level could be as one of the things we can do next meeting physically, and then exchange cards, invite some of the ministers, and then take that as to the press, so that the ministers, when they attend, it goes to the press. And not only that, I want to take it to a higher level. So I want to even take the minutes of this to the Niti Aayog. So some of these I want to do it at government level because things have to happen. They have to drive it. So they're not driving it yet for 100 million tons of coal. That's my concern. So let us do that. And I wish you all the best for all of you. So I'm very happy I could participate in both the 2 days in spite of my other preoccupations. So let me wish you all the best, Anisha. Do well. Thank you.
Thank you so much, Mr. Venkatraman, for your suggestion. Mr. Davi did say that they would like to meet this higher up at the Niti Aayog, and hopefully a presentation would be given on all that was discussed here. And once everybody meets physically, if you all are in Delhi, this is where the Ministry of Coal, Power, all of the corridors of power in Delhi, and hopefully we'll catch up and be able to then put in our representation with more weight in the years ahead. Thank you all for your participation, and thank you for your valid suggestions. Now, I would like to end it here. This wraps up Gasification India and Waste to Energy Virtual Conference 2021. We would like to thank our sponsors who have supported us this year to make gasification and waste to energy a big success. We would like to thank our principal sponsors, Jindal Steel and Bar, Indian Oil Corporation, and Case Group, our powering sponsors, Coal India, our supporting sponsors, Naval Lignite Corporation and Engineers India, and a big thank you to our associate sponsors, Reliance Industries, Avantgarde Systems, and Aquasource Technologies. I hope the last 2 days have been worthwhile for you by bringing you up to speed with the latest technologies available for gasification, depending on the different feedstock and the derivative requirements. By the end of the day today, I hope all of you are now full of new ideas and have made new connections to bring gasification projects to life on a large scale. Till we meet again next year, goodbye.